today is mining frequent patterns, association, association rules, and correlation. So, as the name indicates, frequent pattern, that means the pattern is occurring frequently. Okay. So, patterns that occur frequently in data set or data, we call frequent patterns. So, there are many kinds of frequent pattern, and three well-known frequency patterns are frequent item set, then frequent subsequences, it is also known as sequential patterns, and third one is the frequent substructures. So a frequent item set refers to a set of items that appear together in transactions or transactional data set. Just like if we study sale data of a shop, and shop is a ration shop or some confectionery or some general merchant type shop. And when we study the data sets of daily sales, and we will observe that in transactions, the entry of bread and butter data is too many, or they are occurring together in one invoice or payment say of one transaction. So when two data items which are occurring frequently in transactions, we call frequent data items. Okay. So similarly, a frequently occurring subsequences, that means there is a sequence of patterns. What is the meaning of it? Suppose one pattern occurs, and most likely it may also possible that so and so pattern is also likely to occur. So frequently occurring subsequences, for example, patterns in which customers tend to purchase first a laptop, followed by digital camera, and then memory card. So this kind of habit can be observed in dataset also. And in practice, generally we have this kind of purchasing requirements also. So such patterns are called sequential patterns. A substructure means different structural forms. So here the structure can be graph, it can be trees or lattices. Okay, so we can have this kind of sequence of pattern. So substructural may be combined with item sets or subsequences. So if a substructure occurs frequently, it is called frequent structured pattern. Okay. So similarly, one more term we use, mining frequent patterns leads to discovery of interesting associations and correlations within data. Basically, association means, as we observe in real life, in campus you will see that two students, they most of the time walk together and go to hostel from college, and come from hostel to college. They also go to mess, and most of the time they remain together. So other students will conclude that they are close friend. Okay, so this is nothing new. We in real life also used to do that, has just formalized. So association is nothing. It is occurs in our real life, and we observe day to day practice. So similarly, you will also observe that to a few students, they sit together in classroom. Okay, so teacher can understand that these students are friends. Sometimes you also observe in the institute, there may be group of students. Depending on if you go to South India, then you can find group of North Indian students. And if you are studying in an institute of North India, the students of South India, they may be in one group. Similarly, the people go out of India, even so, Indian and Pakistani can also be good friends. Okay, so depends. Okay, so it is a feature of our routine life. So this association we will study here, and another term is correlation. Correlation of data means how two data sets or how two parameters are related. That means when one varies, how the other is affected. Okay, so we take one simple example how the association rules are represented. What is association analysis? So the association analysis means simply to analyze data set for finding out the association, as the terms indicate, that is the mutual interpretation. So frequently occurring together in transactions. Okay, we analyze data set, and we try to identify those items which are frequently occurring together in transactions. Association rules are written in this form. This is a way of writing the rules. Here I have written buys, it is X computer, and this is inverse. In mathematics, this refers to inverse, but here somewhat different meaning. We will see in a short while. Buys X software, and in this bracket it is written support 1% and confidence 50%, where X is a variable representing a customer. So I will read it like there are customers who buys a computer, also buy a software, and there is support of 1% and confidence is 50%. Now question arises, what are these two terms? We will see what is their formal definition and what is interpretation and meaning. So simply right now the rule is exhibiting that customers who purchases a computer also tend to purchase software. Okay, and basically these two, support and confidence, they are the probabilities. Okay, so we will see here 50% confidence means if a customer buys the computer, then there are 50% chances that he or she will also buy a software as well. Meaning is that suppose one customer has purchased a computer, then what is likely to purchase of software in future time, not right now, in future time. Okay, so that kind of incident we define using probability. What are the chances? So 50% chances means 0.5 probability, or 50%, any form can be. Similarly, 1% support means what? 1% support means 1% of all transactions. Under analysis, we have computer and software together. Meaning is that suppose there are 1000 transactions. Okay. And in these transactions, uh, the items entry, okay, so several items which are available in the shop of a computer or the shopkeeper sales, those item entries are there. And in transaction, the computer and software, and there can be entry for mobile, there can be entry for memory, disk, etc. So many items related to electronics can be there. But here rule says that 1% support means the total number of transactions that we have analyzed. that we have analyzed. 1% of transactions have entry of both computer and software together. We can also say, suppose there are 1000 transactions. So 1% of 1000 means 10 or 100. बताइए भाई, one student need to speak here. What is the value of 1% of 1000?
10.
10, sir.
Okay. So there will be 10 transactions in which we will see that there is entry of computer and software both. Okay. So the rule that has one attribute or predicate, that means bias, it is called single dimensional association rule. Okay. And we represent rule in this form. So simplified representation, instead of showing X, we directly represent in this form. Computer, software, 1% and 50%. So one first value refers to support, other value refers to confidence. Okay. So in future classes, we have the representation of rule in this form. Okay. Every time there is no need to write support confidence here, 1%, 50%. Now, simple explanation has been shown here. 1% say 1% support and 50% confidence. So a customer who has purchased computer have also purchased software. Okay, so there are 1% customers who have purchased computer have also purchased software. And here I have written there are 50%. That means if a customer who has purchased computer and he will also purchase software, so there is a 50% chances. So who has purchased and who is likely to purchase. Okay. So here has purchased or have purchased, and here you see will purchase. Okay. So it is easy understanding for the rule. Okay. So let from a relational database related to sales purchase, a data mining system finds the following associations rule. Okay. So now here somewhat more complex rule. Here it is written age X 20 to 29. This is for end. Okay. So it is income X 40,000 to 49,000, and then buys X. This is written laptop. Support is 2%, confidence 60%. The rule is read like this. From dataset under study, 2% customers in age group 20 to 29 years old with income from 40,000 to 49,000 have purchased a laptop. Okay. have purchased. These customers, okay, have purchased. So they are 2% customers, right? There are 60% probability that a customer in this age group and income group will purchase a laptop. A customer who belongs to this category, income and age, so there are 60% probability. So here there can be several attributes, okay, in forming rules. An association rule that involves more than one attribute predicate, for example, year, age, income, buys, okay, are called multi-dimensional association rules. Okay, this is simple definition. Now, if we consider minimum values for support and confidence, then these rules are called, or these support confidence are called minimum support threshold and minimum confidence threshold. Threshold, you understand, some value, okay. Beyond that, something likely to happen or something will happen, and before that value, it will not happen. Okay, just like in physics, you study photoelectric effect, some frequency value, and etc. So threshold is very common word used in engineering. So I think all of you might be able to understand. So they are the threshold value, and the rules are called association rules that do not satisfy both minimum support, minimum threshold, and minimum confidence threshold may be considered as uninteresting and are discarded. Meaning is that when we perform some data mining activity, we want that the support and confidence value. If I say that the support should be minimum 3% and confidence should be minimum 60%. Okay. So there in my data set, there may be several such items that have very limited number of entry in transaction data set, and those association rules have lower value. So I will say that I am not interested to understand data set or the association between the so and so item. Okay. So in this way, in most of the cases, we always define some threshold value, and it is also one way to define interestingness. I am interested or not interested, or some pattern is useful or not useful. So formally, quantitatively, I can also represent using threshold. Okay. So what happens here during the exercise of data mining, we ignore so and so rules which are not of my interest or which belong to the threshold value. Okay. So it is easy to understand, nothing complex. Further, to uncover interesting statistical correlation between associated attribute value pairs, correlation analysis is performed. It is also a kind of analysis that many students might be aware in statistics, and if you have not gone through, then on in the subsequent classes it may be either addressed or you can also see on internet. So here objective is how attribute values vary, and to know degree of relationship, for example high, low, etc., between two quantities. So we do correlation analysis. So you can see on net correlation, what is correlation, what is correlation analysis, and what is correlation coefficient. So you do this exercise at your own level. So a simplified example we will take now, by which we will be able to understand support and confidence in numerical terms. So suppose a simplified example, computer antivirus software, and support confidence is 2%, 60%. So a customer purchases a computer, he or she also likely to purchase antivirus. So there are 60% chances. And the customers who have purchased a computer and have also purchased antivirus. Okay. So such customers are 2% or 2% transactions that have this value. So suppose there are 2000 transactions. Okay. So 2000 transaction and 2% support means 2% transaction contain both computer and antivirus together. Right? So 2% of the 2000 value will be, it is a simple calculation, it is 40. So there are 40 transactions that contain both computer and antivirus together. Okay. And 60% confidence means there are 60% chances that if a transaction contains computer, it will also contain antivirus software entry. Or in terms of customer, we can also have the same explanation. Now you see here, total transactions were 2000. Out of 2000, 2%, 40 transactions have both computer and antivirus. Now, what about these transactions? These transactions can have entry either computer or antivirus, but both items, computer and antivirus, will not occur together. Right? Few transactions can have only computer entry, and few transactions can have antivirus entry. Now we come here, 60% confidence. How do we interpret it? Let 40 is the 60% of some hypothetical parameter A. Okay. Where A be a number of transactions that contains either computer or both computer and antivirus. Right? This 40 value, okay, it is 60% of some parameter. So if I assume A is some parameter, and if I try to find out 60% of A, so 60% of A will be computed like this, okay, and A will come out from here 66.66. That means there are transactions 60.66 that have entry of what? Computer or antivirus. Chaliye, something is written here, I read it. Therefore, there are 66.6 transactions that contain at least, and few of them contain both computer and antivirus. So here such transactions are 40. Now you see here how it is represented. So 2000 total transactions under analysis, and 2% of such transaction is 40. Now this 40 also defined as 60% confidence. So this value should be 60% of some other value. Okay. So if we compute what is that value, just we calculated, so it comes out 66. That means there are 66.6 transactions that have entry of computer, and out of those 40 transactions are such that they also have the entry of antivirus. Something is clear to you?
Yes, sir.
So we go ahead. Or if you
Sir,
want to ask, you can ask at this point.
sir, I have a question.
Hmm?
Sir,
हाँ बोलो
I have a question.
आगे.
Sir, out of 2000, is there
एक
only
मिनट. हाँ
66.6 computer?
हाँ हाँ अभी देखो. This is 2000 transactions. ठीक है.
Okay. And
And let me speak first.
among the 2000, only 66.6 is the computer, and rest of the transactions are just not the computer.
Rest of the transaction can have entry of other items, including software, antivirus software also.
Okay, sir. Okay, sir. Thank you, sir.
I repeat, there are total 2000 transactions. Out of that, 2% have entry for both. So 2% transaction definitely have items both computer and antivirus. And such transaction you can directly calculate 2%. 40 are such transactions. Now we also say that there are chances of purchasing an antivirus if the customer has purchased computer. So if 40%, if 40 such transactions are there, right, in which both transaction and both computer and antivirus are present. Now I want to know how this refers to 60%. Then definitely the transaction which contain the computer will be what? So if I assume that they are 100, then this value is 60, right? If those transactions are 100, then this value is 60. That's why I say it is 60% chances if 100% of this value. So based on these two values, I can have guess about the future customers. Now it is clear? Or
Yes, sir.
any question? Any other student want to ask any? Okay. So I assume it is clear, and further we will again discuss. Now you can also guess from this explanation. 2% customers who have purchased computer have also purchased antivirus. Okay. And if a customer who has purchased computer, there are chances of 60% he or she will also purchase antivirus. So that means those data items are 60% that we just computed. And of what it is 60%, then we shall assume that some value that is 100. So how to compute that 100? So I have just done that calculation. Now we come classification and regression for predictive analysis. Classification is a process of finding model function that describes and distinguishes data class or concept. So it will be easy to understand by this diagram. So data class or labels. Label here simply name of the class. So name of the class are known in advance for data that are going to classify. So suppose we have data, okay, so large number of data are there. We know about each data what kind of label it has. Suppose they are simply showing the colors, red, green, yellow, etc. So we know each data color is what. Okay. So we study all these data and we try to find out by which rule these different colors can be represented, or by which function we can represent all these different colors. So we try to find out a rule or model or function. Anytime we can use. So more formally, we use the term model. So what more technically we use, we have data, and such data we call training data. Meaning is that by using these data, we make a classification model or rule. Okay. Now, if any new data comes, and I am not knowing what is the label, what is the color of it, unknown data for which label is not known. I am not knowing what is the color. So if this data is given as input to this function or model, it identifies to which color or the label or color of the data, and it will categorize in that class, or it will say that to this class this data belongs. So here labels are known in advance, one thing, and we model trained model means simply we are trying to find out the algorithm through somewhat more uh, easy to function, okay, any kind of. So in general term, we use model. We can also say it is a function. We can also say it is a rule. So today what we have low computation cost. We have low cost computers, and we have no problem of speed and memory. So it is possible today to perform large computation at low cost. So what happens here? We take help of such computation. So it is possible that this model can be developed of high quality. Okay, so if I say it is a mathematical equation, so mathematical equation simply quadratic equation, and if I want to find out the root of quadratic equation in school classes they taught, if I take an equation that is of order x x 15 plus 5 x 14 plus 3x 13, so it's a very complex equation. So that kind of solution, if I want to do by some conventional method, it is not possible. Similarly, this model basically you will see in other classes, machine learning algorithm, or okay, we take help of matrices. Okay, we take so that becomes a formal way of defining this classification model. But basically, it is just a function. So the classification model is used to predict class labels or data object for which class label is unknown. How classification model is presented? The a classification model can be represented using different forms. I can also use if-then rule. I can use decision tree. I can use mathematical formula. I can use neural network. Today, many people use neural network. Okay. So this neural network it provides refined value of computation. So first of all, many students do some project, etc. So first they take data set, they train a model, then they test the model. So how much percentage of data set, this kind of exercise they used to do. And many programming languages support inbuilt function. Okay. So programming has become easy for such kind of problem. Now this is one representation. If youth and income is high, then class A. If age is youth and income is low, then categorized to class B. If age is this much, then class C aged. If age senior, then class C. So this is also a way of representing classification model. If then statement all of you understand in programming, and I can represent it by this diagram. This is called decision tree. So age, then this is income. So based on youth and attribute, I can go this path or this path and this path, and this is the terminating. In a decision tree, leaves represent class labels. Here in this, they are the labels here. So we, by using training data set, we develop this tree. Okay, and we test any new data on different nodes, and finally based on the result of each node we have information to which class or category so and so data belong. In a decision tree, leaves represent class labels. The here each node represents act as a test on attribute values, and each branch denotes outcome of the test. This is neural network. This is what I want to say earlier. We have age and income. They are the F1, F2, F3, F6, F7, F8. Finally, we have class A, class B, class C. So what happens here? Two values come here. There are two functions, and we also these F2, F3. So all these are the functions. So by training, these functions are developed, or but in practice you will see they are the matrices. So here we see in a neural network we use neuron-like processing units with weighted connection between the units. The weights are adjusted such that the overall computation classifies an unknown data object into an appropriate class. Okay. So I think I stop here, and in next class we will discuss. Now, any question you want to ask, you can ask. How many students have purchased textbook, printed copy, or how many students have PDF file, or how many students have nothing? PDF. Third edition. Okay. Third edition you have? Okay. There is another book, and its second edition is useful, but the first edition PDF file is available on net. So I can send you the PDF file of the first edition. Okay. But it is better to purchase the second edition, that is the global edition. This one. Actually, both books will be used for you in long run also. Any other question? Okay, thank you. So now